The title of this lesson is The Quadratic Formula and the Zeros of a Quadratic Function. How many of you remember, in theory, what the quadratic formula is? Not memorize the letters. That's not what I mean. You're like, oh, I sort of remember us doing something like this. Nobody remembers quadratic formula? Oh, yeah, you do pretty much. OK. So I'm going to teach it sort of in between. I'm going to sort of teach it like you basically saw the quadratic formula. It's back in the recesses of your mind. But I'm also going to teach you that you don't know where it comes from. It could be your grade 10 teacher did show you where it comes from. But now with a little more practice, maybe it's a little clearer where it comes from. Yeah? In the past, we have used the technique of completing the square to solve in the past. Like somehow we've been doing it for years. Last lesson, we learned how to complete the square to solve quadratic equations. The idea is we could complete the square, and once we were done completing the square, then we could isolate. We can use this idea to derive a formula. Somebody might have asked the question last lesson. Doesn't this play out the same way every time? Isn't there a pattern to all this? I do the same steps every time, and the answer is yes. So here's deriving the quadratic formula. It starts with any quadratic you get given. ax squared plus bx plus c equals 0. Any question you get to that's got a's and b's and c's. And this is key. This first line is key. Because the stuff I'm going to do next, deriving, you're not responsible for the derivation. I'm not going to ask you to prove the quadratic formula on the test. I just want to do it once so you know I'm not just making up stuff. I'm actually going to use steps you know to take this and make a formula for solving quadratics. Well, there's an important thing in all that. That first line is very important. The a is the coefficient on x squared. The b is the coefficient on x. And the c is the constant term, it's called, the number that's by itself. So don't forget that when we go to use it. That's what the a, b, and c are. So let's talk about the steps to completing the square, which you might be having trouble with. It's sort of a difficult procedure if you don't practice it enough. But I'm going to do those exact steps here, only with a's and b's and c's. And I give you permission to get overwhelmed by this. If it goes completely nuts all the way through, that's OK. You actually don't need to follow it all. Just know that I'm using the steps that I taught you. I'm doing the exact same steps.
Is this on the quiz tomorrow?
No quadratic formula on the quiz tomorrow.
Okay.
Yeah? And my intention, in my brain, I haven't made up the quiz yet, that my intention was that there'll be 3 questions.
Okay.
First one, complete the square.
Okay.
Second one, here's a word problem to complete the square, which I'll give you the equation for. Okay. You won't have to make the equation. I know word problems are tough when you have to make the equation. So it'll be like blah, 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 sales, ticket sales, whatever. Here's the equation.
Okay.
Yeah? And then the third one is right from Friday. Solve this by completing the square.
Okay.
See where you're at. Do those 3, go home. Yeah? No, not go home. I'm going to try and teach you. There's my quiz hints for you that are here today. All right. Same steps with ridiculous A's, B's, and C's. So if you've kept up and done some of the completing the square homework, these steps should sound familiar even if the algebra is tough. First step, common factor off the A value off the first 2 terms. That is, I'm going to divide both of those terms by A. It's OK if you're already in trouble with this. You're already like, what? What just happened? The biggest part I want to get out of this is that you're like, oh, I know that step. I know in theory what he's talking about. He's talking about factoring off that A. After I have the A factored off, I go over here, and most people are right off the side. I don't know whether that's caused by us teachers or it's just something everybody does. They go off to the side and go, OK, I need the magic number here. I need to take this B over A that I have now, right there. I need to divide it by 2 and square it. And I know what happens at all levels of algebra. I was just teaching a calculus lesson. It's still on the screen here. Maybe I'll show you the algebra lesson they were doing. That's what they were doing. I don't do that to show off or to scare you. I just go, I know what happens. I get partway through something, I can see them go, I've done all I can do now. Yeah, and that happens in lessons. And it might be happening to you here. You're like, b over a divided by 2. How am I supposed to go b over a divided by 2? Hold on. It's not quite as bad as it looks. Dividing by 2 is the same as multiplying by a half. And then multiply the numerators together and the denominators. And squaring's not so bad. Square everything, I get b squared over 4a squared. And if you sort of remember the quadratic formula, it sort of might be clicking here like, oh, there's a b squared. I think there was a b, wasn't there a b squared in the quadratic formula? You're thinking, okay, and that's where this comes from. So that's the magic number. And if you didn't get all that, but you do want to remember this, that's the number I add and subtract. Let me just say this again. What I'm doing here is not on the quiz. It's not on the test. It's not in the exam. It's just me showing that what I'm going to come up with here is just using the same steps that you can do, which is I common factored off a, and then I divided that thing by 2 at b value, that number in front of the x, and squared it. Now here comes the toughest line. The rest is not too bad, actually. What's the number that goes in the brackets then? You'll have to have done some homework to know the answer to that. B over a divided by 2. That thing right in there. And maybe are you getting it from here? Is that how you remember it? Yeah, interesting. You can take this and divide it by 2. You can take this and square root it, or the other place I suggested to find it was right here, right before you squared. That's that number there. So I get x plus b over a, b over 2a. And then this becomes I've done something really scary there. Really scary. Oh, and on the quiz tomorrow, I promised you a mark just for this step right here. Just to draw that arrow, because I know that's the most common error. And when I multiplied that by a, it just canceled with one of the a's in the denominator. And that's why it's only b squared over 4a. Maybe you'd like an extra line there. And maybe you're right, but I did it all in one step. Whew. What a mess. What a mess. The next step, though, was, notice, there's only one type of x term here. And one of the things I was trying to talk about in last lesson was once you only have one type of x, you can start to isolate. So here's me starting to isolate. Brought those two terms over. And while they're there, I'll get a common denominator. I'll get them together into 1. So this is b squared over 4a. I'll picture the c as over 1. So that becomes 4a times c is 4ac over 4a. Starting to see it now, those of you who do sort of have the quadratic formula memorized. There's the b squared minus 4ac. And again, if you don't get every single step, that is totally fine. I'm not giving you permission to just ignore all this. I'm just saying, if you're sort of following what I'm saying, that it's the same steps you did in the other lesson, just with crazy algebra, like absolutely ridiculous algebra. If you just sort of follow that, it's good enough for us. I'm going to tie that up now. B squared minus 4ac all over 4a. All I'm doing is isolating x at this point. Next step is to divide by that a, which I will show the extra step this time. I hope I don't run out of room here. Divide by a, which can be upsetting. Divide by a, how am I going to divide by a? Well, it's the same fraction work we've been doing, only with an a this time. I'm going to multiply by the reciprocal. How do I reciprocal an a? Well, I multiply by 1 over a. Oh, I lost my squared there. I was so focused on the right side, I forgot that side's still squared. Now I'll do that. That's not so bad now. B squared minus 4ac all over 4a squared. Those of you who know the quadratic form in your head might be panicking a little bit. You're like, I think he's made a mistake. It's not 4a squared in the bottom. I know it's not 4a squared in the bottom. He's messed it up. Yeah, maybe. Something's going to happen here. Yeah, I'm not done yet. I've got a space problem now, don't I? I should have used that over there, but anyways. X plus b over 2a. I'm going to bring the squared over. What's the inverse of squaring? Square root plus or minus square root. There's the plus or minus in the quadratic formula. And look at that, 4a squared actually does square root. The top doesn't square root very nicely, but the bottom does. And I get plus or minus square root b squared minus 4ac all over 2a. And I got b over 2a to bring over. So I'll do it in one last step. I'm going to grab this, and hopefully Sydney's not going to yell at me. So grab all that.
For the interruption, all students applying for university, please go to the cafeteria now for the university application workshop. Again, all students applying for university, please go to the cafeteria now for the university application workshop.
Not applying for university ever, as in if you're going to university next year. So that's any grade 12 students should be going to that thing. I don't think we have a 12 in here, but if we do, yeah, then you should go check that out. I just brought the b over 2a over. It already had a common denominator, and there it is. Now, when you first saw that in grade 10, most of the grade 10s get very upset. They're like, are you out of your mind? Well, this time around, after doing that homework where you had to complete the square to get zeros, during the homework, maybe you were like, please tell me there's something better than this. You can't tell me people are going through all these steps every time they have to solve a quadratic. And the answer is no, they're not. They're using this formula. This formula does exactly what your homework was doing, but just jumps right to the end. You don't have to complete the square to do it all. It does it all by itself. You just put the a's, b's, and c's there. I haven't taught that part of the lesson yet. I haven't taught you how to use it. In fact, if someone came in right now and was late for the lesson, all stressed, sorry, my bus was late and sat down. Mike, don't worry. I was just showing where this came from. If you want to see where it came from, you can watch the video, but that's not what you have to be able to do. What you have to be able to do is what comes next. This is just me proving it's not coming from outer space. It's not just something somebody beamed and said, here, use this. This is doing the exact same steps you were doing in your homework from the last lesson. I factored off the a. I got the magic number and added and subtracted it. I factored, multiplied it out, and isolated x. I said that fast on purpose. I just was doing the same thing. But I know it's ridiculous. With all the b's and a's and c's, who's keeping track of all this stuff? Only me. I'm the only one who has to keep track of all this stuff and be able to do all those steps. Do you have any questions about those steps? I kept it moving on purpose. I didn't want to use up all your brain power right there, because you don't have to use any of your brain power there. Do you need more time there? Here's where you need your brain power, right here. There's the quadratic formula. That's the way I could have taught the lesson. I could have walked up and said, mathematicians figured it out. Anytime you have any quadratic you want with a 0 on that side, ooh, let me repeat that. Any quadratic equation you want with a 0 on that side, you can get the answers by using this formula. It looks ridiculous to memorize, but you must memorize it. Now, many people, if they just do the homework, will have it memorized by the time they finish the homework, because they'll write it down so many times. But if not, get it memorized, because you need it. You need it. You need it. It's not going away. You won't show up in advanced functions like, oh, don't even worry about it. We got a better way now. for quadratics? No, we don't have a better way for quadratics. This is the way we solve quadratics when they won't factor. If they'll factor, we still would like to factor. I almost jumped ahead, but we're still in copying mode, aren't we? On purpose. I did not photocopy on purpose, Mike. They need to write that down. The solution for a quadratic equation, that's ax squared plus bx plus c equals 0, underline the 0, is given by the quadratic formula. X equals negative b plus or minus square root b squared minus 4ac over 2a. Is it, am I getting some of the rust off your brain from last year? You're starting to go, oh, wait a minute, I do remember this disaster. Yeah? Well, I'd pause for questions, but I don't know what the question would be right now. The question would be, how do I use it? But that's what I'm going to do next. I don't know what someone would ask here. Has to be 0 on one side. And then the a, b, and c is just the coefficients of the different pieces. That is, a is the coefficient of x squared, b is the coefficient of x, and c is the constant term, or the term that doesn't have any x. Do you need more time?
It's okay. Calm down. He's getting all angry, Mr. Todd. I don't know why.
I can probably guess why.
I wasn't even doing anything. He just started hitting me.
And Nathan, I have 4 kids. And every single time, 2 of them come to me with an argument.
It's one way all the time.
Yeah, it's never one way. It's like, at most, it's like 90-10. So I always stare at the one that's not complaining.
Carter was the one punching stuff.
Carter was still pacemakers over here.
I believe Carter had a part to play in this. I just don't believe that you were sitting there innocently.
I was telling him to calm down. I was being good moral support.
Mm-hmm.
See, he's trying to hurt me again.
Here's what your questions will look like. Use the quadratic formula. Here's the steps. If you don't remember, or if you're having trouble with these, here's the steps. The first thing you do is you go up here and go, all right, is it equal to 0? Yes. Underline the 0 and go, yes, it's equal to 0. It's ready to do the quadratic formula. And then you just label these. There's A, there's B, and there's C. Those are the 3 pieces you need. If you identify those, and you have the quadratic formula memorized, the rest isn't bad. You just plug it in. X equals negative b plus or minus square root b squared minus 4ac over 2a. I have it memorized. Now it's just sub it in. Negative b is negative 7 plus or minus square root b squared minus 4ac. You just plug them all in the spots that the formula tells you to. Those of you who didn't do your homework are at a disadvantage here, not because, oh, you didn't do your homework, now you don't understand. That's not what I mean. Those of you who did your homework and tortured yourself with that and texted and emailed me and just pounded your way through this, you are glad to see the quadratic formula. You're like, oh, this is awesome. That's way better than what I was doing in that homework. It just pops right to the answer. I don't have to complete the square. I don't have to isolate. I don't have to keep track of anything. The quadratic formula does it all. Those of you who didn't do your homework are like, well, I don't like this either. I'm like, well, then you should have tried the homework. And you would have found out this is darn good. This is awesome, the situation you're in. Because your calculator can do a lot of this work here. Your calculator can handle negative 7 squared minus 4 times 6 times negative 3. I'm going to try and do it in my head just to try and stay young. But meanwhile, you get your calculator and check to see if I do it right. Starts with a 49. Those 3 is 24 times 3, 72. So 49 plus 72 is 121. Has anyone got their calculator out to see if Mr. Todd's getting old or not? Is it good? Okay. When I can't do those in my head anymore, that will be when I retire. Right in the middle of a lesson. Wouldn't that be awesome? If I got it wrong right there and I was like, nope, that's it. Put the pen up, went home, bought my brand new dog and went home. That's a joke between me and Mr. Todd. I keep telling her I'm going to buy a dog the day I retire. On the way home. It's at least 10 years away. Square root of 121. 11. That one's square roots. You got your calculator to check. You're not worried about staying young like I'm trying to do. Do them in my head. So this is 7 plus or minus 11 over 12. If that comes out to a decimal when you try and square root it, we got to talk about that because the question says express answers as exact roots. So if it doesn't square root, don't do it. Leave it as the square root. Actually, the question usually ends there, where you just leave it like that if it doesn't square root. This one, I can go farther. I've either got 7 plus 11 over 12 or 7 minus 11 over 12, which is 18 over 12, which is 3/2. And this one's negative 4 over 12, which is negative 1/3. So those come out pretty nicely. But it also asked for the decimals. So there's the decimals. Is this really starting to ring a bell now? They were supposed to beat you up with it in grade 10. You were supposed to do a bunch of this. If you're right with me, you might be like, so can I not do the questions with the complete the square? Can I just do them with the quadratic formula? No, there'll be at least once on the quiz and once on the test where you have to show that method. The rest of the time you can use the quadratic formula. This is not on the quiz. Ms. Todd, could I use it to check my answers on the quiz? Yeah, sure. Yeah. But I paused for questions. I'm not trying to rush it. What questions do you have about this? Little side note, when the answers come out reasonably nice like this, it probably would have factored. Probably factoring would have worked here. Probably. More time there before I scroll up to do the other side? I have 2 seats up front here in the splash zone. Apparently your eyes don't. Seven minus 11? What is 7 minus 11? I get that though. My writing was a little off there. All right. I know, I'm throwing a lot at you. But what's wrong with this one? Why am I hesitating on this one?
Because it's minus 3, but if you just add 3, then it's 0.
Right. The quadratic formula came from me starting with a 0 over there. So if it's going to be like that, then you need it like that. So you got to go 2x squared plus 8.2x plus 3 equals 0. Now this question really shows off what the quadratic formula can do. Yeah. This question really shows off what the quadratic formula can do. The quadratic formula is completely unfazed by decimals. So when we had questions in the homework, it was like solve by factoring. You're like, so everything in the world factors? No. Very little in the world actually factors. It's usually going to be some crazy decimal mess like this. But the quadratic formula is completely unfazed by that. It does not care about that at all. Whereas if I put this in the complete the square homework, as hard as those questions might have seemed, this is way, way harder. But the quadratic formula is like, no problem. As long as you have the quadratic formula. Okay, if you're having trouble with these, label this. That's the A, that's the B, and that's the C. And I must tell you, I'm going to write them side by side here. I think you'll find it'll be the exact same number of steps for this one as well. You write down the formula. You sub the numbers in.
Either way, one of you guys does it. Both of them.
8.2 squared minus 4 times 2.5 times positive 3.
That's true. 200% that's equal to S.
Ooh. In my head? Huh.
Times 3 is crazy.
No? Sydney? It's a 37. Is it right? Sorry, I had to think it through. Now, can we agree that, like, decimals are already in? I know this whole decimal thing, do I leave it as a fraction, do I leave it as a radical? I know that's a mystery. We really should have taken a week somewhere along the way. Halfway through 10 academic and gone, stop, wait. Let's just talk about when we do decimals, when we do fractions. And we don't. We just sort of let it develop. So if that's stressing you, well, yeah, I'm going to give you little tips along the way. Here's my tip for the day. If there's already decimals in the question, it's already decimals. You don't have to worry about it. You don't have to put it back into fractions or anything like that. If decimals are in the questions, use decimals all the way through, no problem. Okay? So then I get these two things, negative 8.2 plus square root 37.24. That's all got to be divided by 5. And the other answer is x equals negative 8 minus root 37.24 all over 5. And then I just get those two as decimal answers. I think I have no chance here, because I don't think square root of 37.24 does anything nice. Unless it's 6.8. Is it 6.8? I don't think it is. That'd be closer to, no. So I reach for my calculator. I'll be disappointed if square root of 37.24 is something nice. I think it's something disastrous. It is. Whew! Okay, so I punch my calculator. Fraction button, negative 8.2 plus square root 37.24 over 5. Do you get negative 0.42? Okay, and then on my calculator I can just scroll up. I don't have to retype the whole thing in. Change the plus to minus. And I get the other one, which is negative 2.86. Is it good? Yeah. Are those steps hard? Well, maybe, but they're very repetitive. The quadratic formula is very repetitive. There's a whole page of quadratic formula homework. Do you need a whole page? Maybe, but it doesn't take long before you're like, this is the same thing every time. And that's the nice thing about it. Unlike complete the square, which is like, if the numbers are different, the procedure all feels different. Quadratic formula is like, bang, 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 done.
You're asking for.
Questions there? More time? I tried to go slow enough at the end there. More time? Yes, please. I didn't get it. I used my calculator to go negative 8.2 plus square root 37.24, and then I divided the whole thing by 5 when I was done. So I gave you permission to use the technology to hammer through that step. And maybe shorten this down a little bit. Some of you might be like, oh, I can shorten this down a little bit. Now, if you've got a calculator that actually does the quadratic formula, you can't shorten it down that much. You got to show me the subs, the simplify, and the answers. So let me just, as you're getting shorter in calculus, I always say you need to show me the subs, the simplify, and the answer. So if you get really good at these and you just want to show those 3 steps, that's fine. Okay. More time? Yes, ma'am.
I got negative 6.97. I don't know how I wrote that.
Okay, how did you type it in?
Negative 8.2 plus
Oh, if you put the divided right there, it's not going to divide the whole thing. So if you want to type it in that way, go negative 8 plus square root 37.24, press equals to find out what the numerator is. Then go divided by 5 equals. Yeah?
Because it's undefined. It's a variable.
Does that help?
So these are the set X. I don't know.
You guys trying to figure out if your calculator does quadratic formula? Is that what's happening?
No, his for like when he does alpha f like for x.
Yeah.
His equals 5, but mine equals 0.
Oh, you might have to sub that number in. Somebody's already subbed a number in that calculator. Oh, lots more to go. Determine the zeros of the following functions. Set y equals 0. If we want the zeros, we set y equal to 0. And you should ask yourself, is there 2 numbers that multiply to 15 and add to 7? 1 and 15? No. 3 and 5? No, almost. And when that happens, that's where the quadratic formula goes in. So I still want you to look and see if these factor, because if it factors, it's going to be even shorter. Factoring is the much shorter solution. But here we're stuck with quadratic formula. So here's what it can look like. Minimum steps here this time. Write down the formula. Show the subs. Show the simplification inside the radical. 7 squared minus 4 times 1 times 15. I get negative 11. Negative 11. Do you get negative 11? Let's type it in, negative 11. What's the square root of negative 11? You can punch in your calculator if you want.
Error.
Yeah, math error. For our purposes in 11U, that'll be the end of the question. We go, oh, no, hey, there's no square root of negatives. No real answers. And that no real answers thing might scare you like, so is there not real answers out there? And the answer is yes. Yeah. But we don't have to worry about that for a long time. All through high school, it's like, we just stop there. When we get to square root of negative, we just go, that's it. That's as far as we're going to go with it. What does it mean for us? Well, let me switch over to Desmos and show you what's happened here. X squared plus 7x plus 15. Desmos. Here's the graph of the situation. When does that parabola equal 0? It never happens. And that's all that's going on here. That's as simple as the situation is. The algebra is telling you there's no way to get a number on that graph that will make the y value equal to 0. Next one, set y equals 0. And ask yourself, is there 2 numbers that multiply to 9 but add to negative 6.
Negative 3 and
Negative 3 and negative
negative 3.
3. Now let's just compare that, compare my new solution to my old one. You could use the quadratic formula here, but look at this. This factors. So this specific slide was just looking at special cases. First special case, if you get square root negative, you're done, no real answers. Second special case, what if it factors? Hopefully you agree that if it factors, I'd much rather do that than do the quadratic formula. So we always check to see if it factors first, because this one factored nicely first. Now, I didn't write x equals 3 or x equals 3, because x only equals 3. If I were to graph this function, which I will now, y equals x squared minus 6x plus 9. Let me put it on the screen so you can see what that parabola looks like. Oop. See, that parabola only meets the x-axis once at x equals 3. So I don't need to write x equals 3 or x equals 3. It's just x equals 3. Questions there? More time? Okay. This says, determine the number of zeros for each function by inspecting the equation. Apparently, just look at this and be able to know the number of zeros. If I set that first one to y equals 0, how many x values are there that make that equation 0? 2. Okay. At first, it's like, how am I supposed to know just by looking at it? The first one's like, oh, okay, well, that's not so bad. There'll be one here and one there, 2 zeros. So maybe it is possible. Somebody else goes, if you give me this question on the test, I'll just solve for the zeros, and then I'll know the answer to the question. Well, yeah, I'm not going to be able to know if you did it by inspection or not. So you could do that. This is just saying there are some equations you can look at and know how many zeros you're going to get. Next one. Oh, we'll do this one. We'll do C next. How many zeros does this have? How many x values are there that will make this thing equal to 0? There's only one this time. There's only one bracket, so there's only one 0 here. So this is one of those parabolas that would hit the x-axis only once. Is that better? Yeah. Okay, these two are a little mysterious, though. And I think the best explanation is not an algebraic answer. It's a visualization example. Where's the vertex of this one? 1, 5. So that's what you need to picture in your brain, is that's where the vertex is. So now it all comes down to, does this parabola open upwards? And if it does, there's going to be no zeros. But if it opens downwards, there's going to be 2 zeros. Which way does this open? Downward. So I don't know what the zeros are, but I know there's going to be 2 zeros. How about this one? What's this one's vertex? similar spot, 3, 4, somewhere about there, and it all comes down to the opening. If it opens up, there's not going to be any zeros. If it opens down, there's going to be 2 zeros. Which way does this open? Up. No zeros. But again, somebody could go, well, I could just do it. I could just solve for them, and then I'd know the answer. Yeah, you could do that too. If I had set this equal to 0, and I moved the 4 over, it would be negative. Divided by 5 is still negative, and then I have to square it in negative. I mean, you could go through those steps if you had to, if you didn't know just by looking at it. So, I wrote a little note here. For the functions above, it is easy. I don't know about that. Not too difficult. It wasn't really difficult. To call it easy is a little bit of a stretch, I think, by simply inspecting the equations. If the quadratic equation is written in standard form, however, it becomes very difficult. These were all in factored or vertex form, so it was not bad to be able to tell. But if it's in standard form, it's a lot more challenging. But I pause for you to copy that down. So I asked the question. If it's in standard form, how are we going to determine the number of zeros? Is that the end of that slide? I'm going to scroll down. Yeah, it is. Okay, so I can put that right there. For a quadratic function written as y equals ax squared plus bx plus c, how can we quickly know the number of zeros? Very difficult. So I got one more slide to show you.
You have the exact same wingspan, so there's no excuse.
Here, try this one. This one's for you. Don't anyone else try this. Nathan, just try this. No, on the corner of your desk there. Ready? Do it right after me.
Okay.
Don't do it. Don't do it. Don't do it, okay?
You couldn't do that if you wanted to.
I don't think I could with your phone. That's crazy.
You've never seen that before? Kids are too busy on your phones. Shall I do it in slow motion?
Yeah.
Now you can show all your friends this trick. Ready? In slow motion? And go as high as you want.
Let's see.
Do it fast.
Let's see.
That
I was about
you
to
do
actually
fast.
do it mine. Oh, I see.
It looks good, but it's just, it hurts. But it looks dramatic. Everybody's like, whoa. So you can jump way in the air and do it. You do whammo, whammo. But don't get somebody. It's really awful when somebody goes, I can do it, and they hammer their knuckles. That's how we entertained ourselves before cell phones, right there. No, trying to fool other people to smash their knuckles on the desk. The other one we loved at recess was we just bring coins and see who could throw them closest to the wall. Yeah, bottle caps too. And we never really kept all of them. It was just like rounds, you know what I mean? You do rounds, oh, I won that round. Got it this close to the wall, you know. Here it is. Final slide. Sorry, I distracted you with my knuckle demonstration. I know, I've reserved 2 spots for you right here for during the notes. Guarantee you'll be able to see it from up here. Children. Children. Can you 2 stop, please?
He did hit me.
I know.
You hit me.
Because you hit me.
If I have to stop this van, we're not going to Florida.
I would have been.
Sorry, flashback from my trip to Florida. I tried to do better, but I didn't. I wasn't successful. Maybe my new active board will have continuous zoom, so I can zoom it to whatever level I want.
When are you getting
They say before Christmas.
Oh, look at
So that means before June. This pen stopped working the other day. Was it in this class? I had to play around with different pens? That was scary. Be teaching on the chalkboard before the semester's out. Good?
I know you've heard that profanity.
Fast forward to first year university. If you do get a prof that's too fast for you and won't pause like I do, we took to doing alternating paragraphs. You're there with somebody else. They copy the first paragraph, you copy the second. And then afterwards, you copy over from the other person's notes. That was the only way we could keep up because the profs would just go bananas. Are profs like that anymore? No, they post their notes now. They've really modernized, so it's better than it was. But if you're ever in that situation, just make a friend and go, okay, you do the first paragraph, I'll do the second paragraph. All right. The discriminant. The discriminant. In the quadratic formula, x equals negative b plus or minus b squared minus 4ac. The expression b squared minus 4ac is called the discriminant. It discriminates whether this is going to have 0 zeros, 1 0, or 2 zeros. And I'm using that word in a good way for once. It's making the decision. It's deciding how many zeros I'm going to have. Now, if b squared minus 4ac is positive, if what you get under the bracket, under the square root there, is positive, then you'll get your 2 zeros. But if b squared minus 4ac is negative, then you get no zeros, because we can't do square root of a negative. But if b squared minus 4ac actually comes out to 0, you'll get 1, because it'll be plus or minus 0, and that won't change anything. Giving you this ability now. Use the discriminant to determine the number of x-intercepts here. Instead of doing all of the quadratic formula work, all I've got to look at is what's under the square root. B squared minus 4ac, which here is 10 squared minus 4 times 2 times 3, which is 76. What does that tell me about the number of zeros? If what's going to be under the square root is going to be a 76, I'm going to get 2 zeros. Because it'll be plus root 76 and minus root 76. I'll get 2 different answers. Before you get excited about that, let's try another one. What's going to be under the square root for this one? B squared minus 4ac will be negative 8 squared minus 4 times 1 times 16, which is 0. So if you did the quadratic formula, you'd get plus or minus 0. Well, plus or minus 0 are the same thing, so you won't get 2 different answers. You only get 1 0. I hope you can imagine what's going to happen next. Oh, no. Oh, hold on. This one needs a little bit of thought. What's wrong with this last one? Yeah. Which you can be annoyed by. Like, why would you be tricky like that, Mr. Todd? I'm like, well, I just want you to be ready. If you run into that situation where all the terms aren't in standard form, moved over to one side, and I'm going to go b squared minus 4ac, and I get 7.2 squared minus 4 times 6.5 times 5.8, and I think it comes out to negative this time, but I will check it. It's a little too much for my brain. 7.2 squared minus 4 times 6.5 times 5.8, negative 98.96. So no zeros. If I put this in the quadratic formula, I'd get plus or minus square root of a negative, and square root of a negative gives no answers. Somebody says, well, I don't want to keep track of the discriminant necessarily. Could I just start using the quadratic formula and keep going until I know how many zeros I'm going to have? And the answer is yes. The discriminant is just a shortcut there. Any questions there?